Hi, this is Tamim Azizada with Vanguard Instruments, and in this video I'll be going over the Vanguard Instruments CT7000 and CT8000S3's dual ground testing option. This feature enables users to test breakers with both sides grounded and significantly increases personnel safety. Traditionally, when timing a circuit breaker, a DC voltage is applied across the breaker's contacts. The voltage drop across the circuit breaker's main contact is monitored during the opening and closing operations of the breaker. From this data, the opening and closing time of the main contacts can be determined accurately. With this traditional method of testing, both sides of the circuit breaker are grounded while test connections are being made, but only one side of the breaker can be grounded during testing. This creates a major safety hazard as the breaker may be energized by induction from nearby circuits. However, these risks can now be virtually eliminated by a novel test technique that allows both sides of the breaker to remain grounded while testing. Vanguard Instruments' state-of-the-art CT7000S3 and CT8000S3 circuit breaker analyzers offer a dual ground option for testing circuit breakers with both sides of the breaker grounded. With this option, users can safely perform tests with both sides grounded using the same procedures they are already familiar with for performing traditional tests. Vanguard's dual ground testing of circuit breakers requires the user to connect a measurement probe on one side of the grounding cable in each phase as shown here. Vanguard's timers use a novel patent-pending technique for the open and close timing measurement of the main contacts. With this technique, a high-frequency voltage signal is injected by the transmitter embedded in the measurement probe. If the main contacts are closed, this high-frequency voltage signal will cause high-frequency current to flow through the ground loop and closed circuit breaker main contacts. When the circuit breaker's main contacts open, the closed ground loop is broken and the measurement probe's receiver senses the loss of the current signal. The receiver signals are sent to the Vanguard circuit breaker analyzer, and the algorithm in the unit computes the circuit breaker main contact open and close times. To start performing a dual ground test, we will select the time breaker option by pressing the 1 key. Now we will press the 1 key to select time dry contacts. On this screen, we are going to select whether there is an insertion resistor or not, and for this example, we will press 1 for no. On this screen, we will select the timing window. For this example, we will use a 1-second timing window by pressing the 1 key. Now we will select the trigger mode by pressing 1 for internal trigger. On this screen, we will select the type of test to be performed. In this case, we will press 1 to select an open test. Now, hold down the arm switch and then press the start key to start performing the test. Continue holding down the arm switch until testing is complete. Once testing is finished, we will be returned to the main menu. Once we've performed the test, we can print the test results to the unit's built-in thermal printer. To print the test results, select Get Results by pressing the 2 key. We are now presented with multiple options for printing the test results. We're going to select Plot Full Chart by pressing the 2 key. Now press the 1 key to select Thermal Printer. And now the test results are going to be printed on the unit's thermal printer. Once printing is completed, you will be returned to the main menu. Next, we will take a closer look at the test results. Here we have a sample printout of an open test shot. The CT7000S3's frequency setting is shown in the header. The frequency value is used to convert the contact time from milliseconds to cycles. Here we can see the date and time the test was performed. This header section shows relevant test information for the test record. This information is entered by the user before performing the test. The test type is shown in this section. In this case, we can see that the results are from an open test. The contact times are shown here in milliseconds. The equivalent times in cycles are shown in the cycle column. The measured contact bounce duration is listed here in milliseconds. The contact wipe distance is measured and printed under the wipe column. The wipe measurement is shown in millimeters or inches depending on the user's preference. The delta time is shown here. This is the difference between the fastest and slowest contact time. The travel analysis for transducer 1 is shown here. The analysis comprises the breaker stroke, contact velocity, contact over travel, and contact bounce back. They can be displayed in either English or metric units. In order for the CT7000S3 to calculate the contact velocity through the arc zone, the user must first define the 2 points on the travel curve. The 2 analysis points to be used are defined as AP1 and AP2. The V1 voltage measurement is shown here. The CT7000S3 will detect the on-off voltage transition on the V2 and V3 voltage input channels. It can detect up to 3 voltage on-off events and record the times. The measured open coil current is shown here. This last section shows additional test information. We can see that the shot duration was 1 second, there was no insertion resistor in the circuit breaker under test, and the trigger mode was set for internal trigger. Lastly, here is the graphical printout of the test results.